balanced. It really doesn't matter on this one because we are already given our theoretical yield and our actual yield. So all we have to do for this one is take our actual yield, divide it by our theoretical yield, and then multiply it by 100 to get our percentage. So what do we got?
Divided by 12.7 times 42.05.
So 42.05%.
That's failed.
So that is a failed experiment.
So do we write failed experiment or failed yield?
You just do failed X. So you know what you're talking about. Alright, so I can go to the next one, so we can do our multi-step one. So, good news, is everything already balanced in this one?
Yeah.
Yay, it is. So, the good news is we won't have to deal with any ratio problems when we go through this. Now, you do need your molar map out, so that way you can actually do the work. Wish I had my molar map. I don't know what I did with it. Oh well. So, if I begin with 20 grams of lithium hydroxide, what is my calculated theoretical yield for lithium chloride? So if I start here, I have to get to here. So lithium, if I take my 20 grams and divide it by lithium hydroxide, I go to lithium. Lithium is 6.9.
2.2.
So 6.9 plus 1.0 plus oxygen, which is 16.0. So that means I'm going to have, what do I have?
23.9.
23.9. So I will divide my 20 by 23.9 to get my moles.
0.8.
So 0.8 moles of LiOH will actually equal 0.8 moles of lithium chloride. It's a terrible L. So now all I have to do to find my theoretical yield is multiply lithium chloride, the molar mass of lithium chloride. So remember, it's 6.9 for lithium. I go to chloride or chlorine. It is 35.4.
35.4
plus 6.9 is?
I messed it up. 35.4 times plus 6.9. 42.3.
So I will multiply this by 42.3 grams.
Times 8? 0.8.
0.8.
Okay.
And what do I get?
33.84.
So my theoretical yield is 33 point, let's call it 8 grams.
Why they all failed? Do we have any?
No, this is theoretical.
Oh.
So this is what I have to start with. But I actually produced 6 grams. So I take my 6 and I divide it by my 33.8 grams, then multiply it by 100 to get my percent composition. So
17.8.
17.8.
Well, 17.75.
So we'll say 17.8. That's good enough. So this means that I got way below what my goal is. We
Was
want,
that, like, extra fail?
I mean, something like this is very possible because think about what's going to happen. You're going to have an experiment to where maybe somebody spilled some of this one. It could be that. Because if this is a large difference
Maybe
between
someone,
our
got
theoretical.
Like scared and they like.
Could have. The test itself could have been invalid. You could have added too much of it. Maybe your original thing was off and you didn't actually have 20 grams. You only had like 10 grams. Could be anything. So does this make more sense than what was in the notes?
Yes.
Okay. If you just go step by step. Do you want to do one more?
Yeah.
Okay. No problem. Alright, so we have a combustion reaction. So we have our carbon and we have our oxygen. We do need to balance it. It's not too hard to balance. You actually don't have to multiply your first carbon by anything. So if I multiply this one by 3, now my carbon is balanced. If I multiply this one by 4, now my hydrogen is balanced. So I have 6 oxygen plus 4 oxygen is how many?
6 plus 4, 10.
So how much do I need to multiply my oxygen by?
5.
There we go. So now we're balanced.
Oh, that wasn't bad.
Not too bad at all. This is where we'll get a little bit extra step to what we have up top. So remember how they just equaled 0.8 right away?
Yeah.
Now we're going to have to do our ratio. Because we're going to start out with 5 grams of C3H8. That is what is my calculated theory of water. So we have to do 5. Start out with our 5 grams. And we're going to divide that by our 3 C's and 8 hydrogens. We know what hydrogen is 1.
1.1.
So it's going to be 8. And then carbon is 12. So 3 times 12 is plus 8.
44.
Yeah. 44 grams. So 5 divided by 44 is
1.1.
0.1.
So that's our moles.
That's how many moles we have of C3H8. Now we're trying to get water. Now if we look at our ratio, we're going to have 1 C3H8 to every 4 waters. So that means we'll divide this 0.1 by 1, so it doesn't do anything. Just stays 1. But then we're going to multiply by 4. So 0.1 times 4 is 0.4. So that means when we do our ratio, it turns into 0.4 moles of dihydrogen oxide. We then have to multiply by the molar mass. And the molar mass of water is 18. So 0.4 times 18 equals
7.2.
7.2 grams of hydrogen.
Can I go to the restroom?
Yes. And you're asking to go to the restroom will be on YouTube forever.
Huh?
Yes. So this is our theoretical yield. And in this one, we are given the percent already. So what do we have to do to figure out how much we actually made?
You just divide that with the 75% by the 7.2.
Actually, you just got to multiply it by
You multiply by 75, you multiply by
0.75. So multiply by 0.75.
5.4.
5.4 grams of H2O is our actual. So sorry if the notes were a little more confusing. Does this make a little bit more sense than what was on the notes?
Yeah.
Okay.
Yeah.
It's just following your mole map. So basically you're just doing the same thing, it's just adding one extra step to figure out if you actually got the correct thing or not. You're using the mole map to find your theoretical, and then you're taking what your actual is and dividing it by that. So. All right.